Now we will look at solving quadratic equations using the square root property. When you want to use the square root property is when you see a problem where you have something squared equals a constant. So we can use this, and the square root property essentially says if something squared equals a constant, then the base is equal to the plus or minus the square root of that constant. Why that is the case? Think of this basic example. We solved this one actually in an earlier video by factoring. You always look for factoring first usually when you're trying to solve these, but most things do not factor as we find in this chapter. So if I look at something like this, I go, okay, well, I know if I squared 2, I get 4. Also, if I squared a negative 2, negative 2 times negative 2, I'm going to get a positive 4. So to account for that negative, we have to do the plus minus the right side. So we basically take the square root of both sides. You have to do plus minus on the right side of that constant side. And it will save you a little time. It's a little nicer and better way to solve this than by factoring. Because by factoring, I have to subtract 4, then factor difference 2 squares, and then solve each individually. Whereas this quick, we'll solve these all by the square root property. So anything, whenever you're looking at a test or a problem, they ask you to solve any quadratics, if you glance at these problems and you notice, oh yeah, all of these can be written as something squared, and actually I forgot to write my square on that, something squared equals a constant. If I subtracted this 3 over here, I have it. If I subtract the 16 over here, I've got something squared equals a constant. So there's no like degree 1 term like an x term within this. So unless I expanded these out. So let's look at this one. I'm just basically going to go x squared equals 4. I'm going to take the square root of both sides plus minus the square root of that side. That's the square root property. Make sure you do the plus minus. So I'll end up with x is going to equal plus or minus 2. That's it. It's that quickly. Now you can list them, negative 2, comma 2, like this if you want, or just leave it as the x is equal to plus minus 2. There's 2 answers there. Same deal with this one. The cool thing is I have something squared equals a constant. I'm all set and ready to go. I'm going to go plus minus the square root of the right side. This wipes out. I end up getting x minus 2. The radicand is equal to plus minus. Now 3 is not a perfect square, so I'll leave it that way. Now I'm going to add 2 to both sides to solve for my x. Always, whenever you're doing this and you're dealing with this quadratic stuff, plus minus stuff like that, stick whatever you added on that side of the equal sign to the front of the plus minus so you don't have a distributive error or a sign error later on. So I'll end up going 2 plus minus the square root of 3. There's 2 solutions there. You could list them both, 2 minus square root of 3 and 2 plus square root of 3, but you can just circle it that way and that's fine. Now, what about this one? This one I couldn't have solved by factoring. This one I couldn't either, but now I can solve this if anything like this. It's a square root property. I can't, in this one, because it's sum of 2 squared is not factorable over integers, but I'm dealing with a complex number here now that we've learned complex numbers. I could actually basically write it in the form I need. Something squared equals a constant. Subtract my 16 to both sides. I'm going to end up getting my w squared equals negative 16. Then I'm going to take the square root on both sides plus minus the square root of that right side. Square and square root wipe each other out. W is equal to negative underneath the root symbol. Pull your I out. Plus or minus 4i. The square root of 16 is 4. 2 answers, negative 4i and positive 4i. All right, last one is a pretty difficult one just for the way we write it and everything, about as hard as you would see something thrown at you, but we'll run through it just to see, make sure we can do something like this. So I'm looking for, I know it can be written in this form, something squared equals a constant. I'm going to get the something squared by itself. I'm going to subtract 3 to both sides. Now I'm going to use my square root property. These wipe out, and I'm getting 3m minus 5 equals plus minus. I'm going to pull my I out. So I'm also going to write this as 4 times 2. 8 is 4 times 2, and I pull my I out to get rid of the negative, right? I is square root of negative 1. So now I can reduce that. So I'm actually going to do that first before I do anything else. So plus minus 2 root 2i, because the square root of 4 is 2, pull that 2 out. Now my next steps to solve for m would just be add 5 and then divide by 3, but it gets messy looking. So I'm going to add 5 to both sides of the equal sign. I'm going to end up with a 3m equals 5 plus minus 2 root 2I. And then I stick it in front of the plus minus, and then I divide by 3 to both sides. I don't mind if you just divide right by 3 to the whole side. You know, it's a complex number, so the standard form for a complex number is a plus bi. So really, the book will probably write this, if you're doing a problem out of the book, 5/3 plus or minus 2 root 2 over 3i, because you just individually divided that, and just make sure nothing reduces. If it reduces, you want to reduce it, and that would be an a plus bi form. But I don't mind if you just left it 5 plus 2 root 2 over 3i, it's fine. And that would be my answer for something like that. So that's as tricky as they get, and they get pretty messy looking, but we're looking for exact radical form, simplified radical form. So, and that's solving quadratic equations with square root property.